All right, Elston Solberg here, out in the field with the crew from South Country who's working on the crop intelligence, water-driven yield potential model, application, whatever you want to call it. And I just thought this would be a good opportunity because we're in corn, and because corn is so expressive, that I could show you folks out there some of the simplest way to learn the language of a plant. And so if you take a corn plant, a canola plant, any plant, and you strip the oldest leaves off and go up the plant to the newest leaves and place them side by side, you can gather a tremendous amount of information as to what this corn plant is experiencing, in the canola plant, etc. And so we've stripped a typical plant here, and we've had to use this moisture probe to hold the leaves down because Mother Nature is being kind of a cow today. Wind-wise, and what you have is the lower leaves of the plant over here, and then gradually going up to the newest leaf. And if you look at the colors of the leaves, that's the key piece. And so generally speaking, from about this leaf to about this leaf, the color is similar, if not getting darker, and then we get lighter as we get into the very newest leaves. Obviously the old leaves over here are in pretty rough shape, and from a nutrient perspective, there's only 4 nutrients that can be cannibalized from the old tissue and moved to the new tissue. So in other words, when this plant begins to run out of these 4 nutrients, it can send a signal to the old tissue and say, hey, please cannibalize yourself and send those nutrients to me because I'm running out. And those 4 nutrients are nitrogen, phosphorus, potassium, and magnesium. And so what we're looking at here is a net cannibalization of those nutrients from the old leaves to the newest tissue. Now, the way you can discern between those 4 nutrients is that nitrogen initially becomes just a lighter color, and so this is mostly nitrogen here. Phosphorus will start at the tips and the edges and work its way down and in, and the leaf will become translucent. And potassium will do the same thing. It will start at the tips and edges and move its way down and in and look burnt. At this growth stage, it's hard to know exactly, but if we had soil tests and tissue tests, we'd be able to identify what was truly going on here. Main thing is there's only 4 nutrients, N, P, K, and magnesium. Magnesium is going to look a little different. It's going to be cloudy. It's going to be mottled. So it's going to have darker spots and lighter spots. It's called mottled. Now the cool thing about this particular example is these leaves are all pretty much the same color, but when we get to the newest tissue, it's lighter in color. And so this is some nutrient in the plant that isn't mobilized, cannot be cannibalized. My first guess would be in corn would be sulfur. My second guess in corn would be zinc. If this was a canola plant, my first guess would be sulfur. My second guess would be boron. If this was a wheat plant, my first guess would be sulfur, and my second guess would be copper. So just to restate what I've talked about here, if you strip off the old leaves to the newest leaves, place them side by each, whenever you see older leaves in trouble like this, less intensely green, it's either nitrogen, phosphorus, potassium, or magnesium. And if you see newest tissue that's lighter colored, showing weird symptomology, the first guess is usually always sulfur, followed by whichever micronutrient that's respectively the first to show up in the crop you're dealing with. So there's a little tidbit. A whole lot of agronomists, a whole lot of farmers have never seen this before. A whole lot of people don't know those factoids. And really, at the end of the day, it's really simple to remember. There's only 4 that can be cannibalized. That means all of the rest of them cannot be. And if you can remember that and connect some dots and thoughts as you walk your fields, it's the essence of plant speak.